Welcome to a normal working day at your industrial premises. Meet Mahesh. He's your maintenance manager and is a duty holder responsible for electrical safety on your site. Though Mahesh is an electrical engineer, he has Kumar, who is an electrician working in your industry and is supervised or managed by Mahesh. Mahesh asks Kumar to carry out risk assessment and then repair a fault reported on switchgear powering operations in the process. This establishes that Mahesh has discharged his responsibility or Kumar is qualified to assess or work on the fault. Before coming to how he accomplishes his professional activities in the industry, let's find out more about Kumar. He is 38 years old, married and happily living with his wife and kid in their home. He has experience of 12 years working as an electrician, or this is his third job. Now coming back to this normal working day in the industry, Kumar makes the equipment dead first as per the SOP. He then opens the panel, tests for dead and starts working on the switchgear. Upon inspection, he identifies a burnt isolator that needs replacement. While performing the operation, he accidentally drops a spanner. The spanner is about to make electrical contact between two live phase conductors left exposed, resulting in a short circuit. This will generate sufficient heat to vaporize surrounding metal parts, creating an explosive pressure wave and sending a conducting plasma fireball. This plasma fireball temperature is above 20,000 degrees Celsius, which is almost 4 times the surface temperature of the sun, directly into Kumar's path. Kumar will not be protected from the blast or will suffer horrific external and internal burns. 3 days later, Kumar will die in the hospital as a result of his injuries. This will leave his family without a father and a husband. The tragedy in Kumar's life resulted from the failure of proper assessment of risk. His supervisor and the industry is personally and legally responsible for this incident or will face stringent action from the electrical inspectorate. Electrical faults can be more dangerous because they may not always be visible or show obvious signs. Hazards get worse when a risky disconnect occurs, and assumptions by managers about equipment use and user competency may not match the actual situation on the shop floor. Arc flash is a low-frequency, high-consequence event. Arc flash incidents are rare but serious events. People may become complacent due to their infrequency, but when they do happen, like in Kumar's case, the devastating consequences, such as the loss of life, are very real. Let's rewind and see how Kumar's life could have been saved. The process should consist of 4 steps for arc flash hazard management as follows: 1. Prediction. 2. Prevention. 3. Protection. 4. Publication of findings for warning users. Firstly, prediction. After making an initial assessment, we calculate the severity of the thermal effect of an arc flash on a given piece of equipment following the IEEE 1584 standard for performing arc flash hazard calculations. In case of Kumar's incidents, the assessment could have taken 4 factors into consideration: 1. Distance to the worker. 2. Voltage. 3. Prospective fault current. 4. Disconnection time. Computer modeling of these factors result in a value for incident energy. This incident energy is a key component in assessing risk and devising measures to prevent. Second, prevention. Mitigating steps can be taken to prevent an incident from occurring by designing it out, eliminating it, or removing a hazard at its source. With arc flash, completely eliminating the risk is very difficult in practice. This means trying to reduce the incident energy released by an arc flash or keeping personnel at a safe distance from the equipment. Third is protection. We cannot ignore the reality that the arc flash risk cannot be eliminated completely. So, the personal protective equipment suitable for the level of risk involved, as calculated in the previous steps, should be used. Fourth step is publication. All risk assessments must be recorded and may also require field marking and safety signage. Safe systems of work, safety rules, and procedures should be devised and documented, with training delivered to anyone affected. Risk assessments need to document the severity of the hazards and measures taken to mitigate them. They should be dynamic and task-based, available to those carrying out work, with the facility for continual reassessment based on environmental conditions and the state of the equipment. Let's go back to the arc flash incident. As before, human error has meant that despite Kumar thinking the equipment was off and following safety rules, a spark happened when a spanner touched a fuse switch. But this time, the incident energy of the flash is below 5 calories centimeter square, thanks to risk assessment carried out on the equipment, which also includes the undertaking proper coordination of protective devices. Moreover, Kumar is wearing PPE appropriate to the hazard. So, the arc flash occurs but at the reduced energy, which results in less physical harm and injuries. This process represents a success for the proper health and safety systems and processes, more importantly saving Kumar life. We at SAS Powertech Private Limited have been helping facilities reduce the impact of arc flash analysis or secure working electrical teams. We have helped facilities enhance the electrical safety or uptime by undertaking detailed assessments, conducting analysis on power system software, and suggesting remedial solutions to reduce the duration of the arc flash incident, if any. With a decade-long experience and with over 1,000 plus studies, we can certainly enhance the electrical safety or reliability of your facilities. Arc flash analysis is mandatory for facilities having connected of 250 kilowatts or above in India. The following regulations demand conducting arc flash analysis. NEC 2023 Part 1 Section 2214.5, page 375. And CEA 2023 Regulations for Electrical Safety in Working Facilities. Connect with SAS Powertech today and secure your facility from the hazardous consequences of arc flash analysis.